Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students. Let us continue with Chapter 10, Force and Types of Force. In the previous session, we have already discussed that what is force and what are the different effects of force. There are 7 different types of force which we are going to study in this chapter, and they are as follows: muscular force, mechanical force, gravitational force, magnetic force, frictional force, electrostatic force, and combined force. In this session, we are going to study muscular force, mechanical force, and gravitational force in detail. Let us start with the muscular force. The force applied with the help of muscles and bones of the body is called muscular force. Let us see few examples. In this picture, you can see the person is trying to move the boat ahead with the help of an oar. For that, he needs to apply force with the help of muscles and bones of his body. In this picture, the person is lifting the weight with the help of the muscles of his body. Here in this picture, the boy is trying to pull the trolley with the help of muscles and the bones of the body. So, in all the actions shown in these 3 pictures, the movement takes place with the help of bones and muscles in the body. And thus, the force applied with the help of muscles and bones of the body is called a muscular force. Next is mechanical force. The force generated by means of a machine is known as mechanical force. We use different machines for doing many tasks in our day-to-day life. One of the machines shown over here is a sewing machine. You must have observed this machine, and many of you might be having it at your home. This is a mixture grinder. And this is the washing machine, wherein you can see the clothes are spinning inside it. Muscular force is used for running some machine like the sewing machine, whereas some machines are run by using electricity or fuel. Mixture grinder and washing machine are the examples of these machines which run on electricity. And the vehicles which we are driving, they are the examples of the machine which run on fuel. Now observe the picture very carefully. A pencil is dropped from a certain height, after which it is falling down. Here in this picture, when a ball is thrown in the upward direction, after reaching a certain height, again it starts falling down. Why is this so? Here comes the gravitational force. It is because of the gravitational force that these objects, they are falling down. Let us understand what is gravitational force. This is the picture of Sir Isaac Newton. He was an English mathematician, physicist, astronomer, and author who is widely recognized as one of the most influential scientists of all time and as a key figure in scientific revolution. He is well known for the formulation of laws of motion, which are famous as Newton's laws of motion. He is also well known for the discovery of universal law of gravitation. he discovered gravitation in 17th century. The force applied by the earth to pull the object towards itself is called gravitational force. Observe this picture. There is a popular story that Newton was sitting under an apple tree and suddenly an apple fell on his head. And then he started thinking that there must be some force at the center of the earth, which is nothing but the gravitational force, which is acting on this apple, because of which it is falling down. Not only this apple, but the gravitational force is acting on each and every object, because of which those objects are falling down towards the earth. The earth's gravitational force acts in the direction opposite to that of an object moving upwards. We have already seen this example before. A ball is thrown in the upward direction. After reaching certain height, the ball again starts moving in the downward direction. Now, what happens here? When the ball is thrown in the upward direction, initially the ball will move up with some speed. This speed, it decreases. At certain height, the speed becomes 0, after which it starts falling in the downward direction. And when it is falling in the downward direction, again the speed of the ball increases because of the gravitational force acting on it. This picture shows a solar system. Sun is at the center, while all the other planets are revolving around the sun. And satellites, they revolve around the planets. Now, here the sun is exerting a gravitational force over the planets and the satellites. So, why don't all the planets and satellites fall towards the sun? Observe one more picture. Here in this picture, the helicopters are flying in the sky. Now, gravitational force is acting on each and every object. Then, why don't all the helicopters fall down? The answer to both these questions is that there are some other forces which are also acting along with the gravitational force, and they balance the gravitational force. That's why those objects are not falling. Here, the planets, they are moving so fast, their speed is fast enough which keeps them moving in the elliptical orbit around the sun. Here also, the force exerted by the machines in the helicopter, it is greater than that of the gravitational force, because of which the helicopters are flying in the sky. Now, in this picture, you can see a boy is dropping a stone in a bucket which is full of water. Initially, the boy is dropping the stone from the height of around 20 centimeters. Then, the boy is dropping the stone from the height of around 100 centimeters. Now, what is the difference in the sounds in the two actions shown in this picture? Here, the sound will be less when the boy is dropping the stone from the height of 20 centimeters, whereas the sound of the stone will be more when it is dropped from the height of 100 centimeters. And what can you conclude from this observation? Here, in this case, when the stone is dropped from the height of 20 centimeters, the gravitational force which is acting on the stone is less as compared to the gravitational force which is acting over here when the stone is being dropped from the height of 100 centimeters. the gravitational force is more in this case when it is dropped from 100 centimeter height. So you can see more water is splashed out. More is the gravitational force, more water is splashed out. Observe this picture. Here, the action of lifting a sack are shown. One sack looks empty. This one is empty while the other one is full. Now, what is the difference that you notice in the way the two sacks are lifted? The gravitational force on the empty sack is less as compared to the sack which is heavy. The gravitational force on the bigger sack is greater. In other words, the bag weighs more. The gravitational force acting on an object is called the weight of that object, and greater force must be applied to lift a greater weight, and that is why in the second case here more force has to be applied. So today we have seen muscular force, mechanical force and gravitational force. In the next session, I will start with the magnetic force and frictional force. Thank you so much.